So this morning, the first chapter is Module 4, where we talk about working with databases. So by the end of today's first chapter, Chapter 4, you should be able to configure your database environment for Genero Studio. We're going to look at the configuration options again. We looked at those briefly yesterday, but this is probably the appropriate chapter for that, so we'll revisit it. Configure your runtime behavior in a special configuration file we call the FGL profile file, a very important file in the Genero environment. We'll take a look at that and all the different ways that you can set the FGL profile. We'll talk about the purpose of the Genero metaschema file. There's actually a pair of metaschema files that we'll talk about here. How to extract the metaschema file. How to connect to a database, the different connection options that we have to connect to a database, and a few more topics specifically about writing portable SQL. So when you're working with databases, you have to have, of course, a database connection, which is defined as a session of work opened by a program to communicate with a specific database server as a specific user. So that's the definition of a database connection. We talked yesterday as well about Genero's Open Database Interface, the ODI, and we were saying that it allows you to connect to any of the supported databases. The embedded SQL that you use in your program is mapped to the specific database that you're connected to by the Open Database Interface. It supports open database connections to any of the supported databases. You can even have multiple connections to the same database at the same time, or a connection to one database we support and a different connection to a different database we support, all simultaneously. Before you work with database connections, it's important to verify your settings for the database client software that, of course, is used with the specific database that you're working with, and having environment variables configured correctly as well. So I guess the first thing here would be to make sure that you have your database client installed and configured correctly, and then we'll worry about setting the environment variables. We can do that through Genero. When you work through Studio, you can configure your database environment through this configuration management screen that we saw just briefly yesterday. So again, we'll revisit that today since this is the appropriate chapter for that. So if you remember from yesterday, I'll just pop it up here again so you can see the live view of it. This wrench symbol down here in the right-hand corner, we also have the wrench symbol up here in the top in the toolbar, so you can click it there as well. Brings up the configuration management interface. And we talked briefly yesterday about your configurations that you can create and configure. Over here on the left-hand side is where you can find those and create additional ones if you need to. So we just have the default configurations here for my installation. We've got a desktop configuration and a separate configuration, of course, for web. So when we use the Genero web client, we have a different configuration. So over here in the middle we have our environment sets, and this is where we can go to configure our environment variables and configure the database that we want to use during our sessions with this desktop configuration. So when you install Genero Studio, it actually comes with a default SQLite installation and configuration. So here's this SQLite that's already selected for all of our demonstrations and all of our sample databases, for example, that you can find in the welcome view. So it makes it easy for someone new to Genero to get in there and just start working without having to worry about doing a lot of database configuration. But when you're ready to start working with your own database instead of this default SQLite configuration, it's pretty simple once you have your database configured outside of Genero to go in here and configure your configuration management settings. So for Informix, for example, we just go up here and select the Informix database option, deselect the SQLite option, of course, and select the Informix option. And then here's our different environment variables that we need to have set to be able to access the Informix environment. There's the famous Informix server environment variable, Informix dir, path, and of course you can add any additional ones if you need to by clicking on the plus symbol. So we talked about that briefly yesterday, but it's always good to revisit. So there's changing the database configuration. We just looked at that, showing an example there for Informix Server. And here we're talking about the FGL profile configuration file. So the FGL profile configuration file has a lot of configuration parameters for databases. There's a lot of things that you can put into the FGL profile file, but here we're going to focus on connection parameters since we're talking about databases. So here's some examples for database connection parameters. That source attribute that you see there is defining the source database. Uh-oh, I just had a pop-up that says I might have degraded audio quality. Every once in a while it does that, so very briefly here, let me just check. Give me a hands up if you're still able to hear me okay. Okay. All right, thank you. Every once in a while that pops up, and sometimes it's serious and sometimes it's not really anything. Okay, so the FGL profile configuration file where we can put our database connection parameters. Your installation, your Genero installation, comes with a default FGL profile configuration file. It's under the BDL installation directory in the etc directory. You're not really supposed to edit or change that default FGL profile file. Instead, what you're supposed to do is make a copy of it, just like you would any other important configuration file, and then edit the copy. And that way, if you make a mistake, of course, you don't mess up your original that you use as a template. So you make a copy, make your changes to the copy, and then you can add all of your database-specific settings, connection parameters, to the FGL profile. So here's just some examples, just to show you what they might look at. Here's an example of connection parameters to connect to an Informix database. And here we've just got our typical database specification that you would see for Informix. They use the database server at, database name at database server syntax for connecting. So that's your typical Informix connection parameter, or database specification settings. And then right below that is the specific driver that we need to use to be able to communicate with that Informix database, DBM IFX9X. You can find a list of all these drivers notice here on the slide it specifies. If you go to the BDL installation directory, which they call FGL-dir, right under there there's a DB drivers file, and you can see the list of supported drivers. So that's how you know what to type in here by looking at that list. You can easily find the appropriate driver for whatever database you're using there. Now notice in this example, we've also specified a username and password file, a password here. Typically you don't want to do that, so we've got a big caveat here that says the username and password should only be set for testing or development here. And that's because it's not encrypted, so it wouldn't be secure to put your password here. On the next page we'll talk about authentication methods and setting usernames and passwords. There's a lot of different options besides setting your password here in the FGL profile file. It's not a good practice to do that. So that's just an example for testing. The second example here, this is a totally separate set of connection parameters separated by white space here. So this one is for a SQLite database, specifically the Office Store database. So this has my source settings for connecting to this Office Store SQLite database. So there I've specified for SQLite the location and the name of the .db file, the database file that SQLite uses for databases. And then of course the driver would be different for SQLite, so there's the driver specification right below. So just some examples of what the FGL profile has in it for connection and connecting to different databases. I mentioned earlier that there is a default FGL profile file that has a lot of these same settings, not the one for Informix, but for all these SQLite sample projects that come with Genero. This default FGL profile, it's actually not the default one, it's out in the samples directory, it's where I got this, has the settings to connect to these sample databases that come with the software. So since I kind of bungled that explanation a bit, let me just show you different places where you can configure the FGL profile. So first, just again, there's a default FGL profile that's in the BDL installation directory, that FGL dir that we saw previously in the FGL dir etc directory. So that's a default one that you can use for a template. And if you don't have another FGL profile configured, it will find that one and use that one. Right, so that is the default if you don't have an additional one configured. Another place that you can configure a customized FGL profile, once you've had a chance to customize it, put your appropriate database connection parameters in it and so on, is you can configure it here in the configurations. Up here at the top, same place we were looking at a few minutes ago to see how you can configure your database settings, there's a profile environment set that's already built in. So you can just select that profile environment set over here. You can edit the FGL profile setting and then specify the path. This will just be a file, right? And specify the path. Browse for the path of your customized FGL profile. So that's the way you can set the FGL profile environment variable and specify the path to your customized profile configuration file. So that's one way to set it for the entire configuration, right? So when you're using, in this example, this desktop configuration, it will be using the FGL profile file that I've specified there in that environment set. Now another way to set it, and I usually use this method for class purposes, is you can also override the default FGL profile and that environment setting that we saw there for the configuration by setting it here in an actual project. So application level FGL profile is fine. There we go. So notice for class purposes, I've gone in and configured an FGL profile environment variable just for this particular set of applications, right? So it's really a project/application level configuration. So I had a specific FGL profile that I wanted to use that referenced this built-in or sample SQLite database. So I set this FGL profile that points to those sample databases here for my project. So that's a way of setting it just for this specific class project so that all of my other projects that I work with are still referencing my usual database connections. So that's a way to override the defaults just for maybe a specific class or a specific project. All right, so that's a bit more about the FGL profile. We've got our database connection parameters configured there, and we talked a bit about how to configure which FGL profile your application will actually use, your project will use when you get ready to start working on your sources and your files. So we mentioned a minute ago that it's a bad practice, not a good practice, to configure your login and password information in the FGL profile. It's not a very secure way to do it. So instead, you should use one of your database that you're working with supported authentication methods. And there's usually more than one to pick from. It just depends on the specific database that you're working with. For example, Informix, Oracle, and SQL Server all support OS authentication. So a lot of times folks just use simple OS authentication when they're connecting to Informix, Oracle, or SQL Server. You can use the connect to clause in your application to connect to a specific database using the user and using clause, right, the connect to statement with that clause. You can also configure a variety of other methods if they're supported by your database server, trusted connections, LDAP authentication, single sign-on, and so on. Again, most of this information is just informational here in class. We won't go into the specifics of configuring all these different authentication methods because they are database specific. Now, one method that is described in detail in our BDL user guide is something called the connection callback method. There's another method here that we're kind of providing if none of these other options work well for you. Essentially, there's instructions on how to configure an FGL profile entry with the name of a function anytime you use the database instruction in your BDL program to connect to a database. It doesn't work with the connect to connection method, right, statement. It only works with the database instruction. But you can define an FGL profile entry with the name of a function whenever the user runs the application and that database statement is executed. It actually will cause this function to be called, and then it allows the user to provide a username and password dynamically. So you can see some examples of how you need to create that function, what that function needs to have in it to work properly in the BDL user guide. So I just wanted to refer to that here so that you would know there are some options that you can use with Genero for authentication if some of these other methods don't apply for you. There's a specific address. One thing about the documentation in our help now is that you can actually specify a specific address and it will go to that particular topic in the documentation. So if you've downloaded the PowerPoints this morning, you can just kind of copy and paste that in maybe. Database schema files. When you're working on your source, working on your programs, working on your forms, we'll talk more about forms today, we don't have to keep actually connecting to the database to be able to define variables like a database column, to be able to look up information about database columns. We don't actually have to connect to the database to do that because of the existence of these special metaschema files that Genero uses. We have a metaschema file that has all the database structure information in it that you actually create by extracting the information from your selected database. So it extracts the information, creates the schema file, and then when you're working with Genero and you're working and developing forms and applications, it's actually just using the schema file instead of having to look at the actual database. So again, another one of those conveniences that we were talking about yesterday. There's two types of database metaschema files. There's a .4db that we use with just standard Genero projects, and then there's a special version of a schema file that has an extension of .4dbx that's used with our application modeling that we talked a bit about yesterday. So the business application modeling has its own kind of version of a schema file that has some more enhancements and enrichments in it for generating applications. So these metaschema files are required anytime you're using Genero Studio and you click on the database schema to open it up. You want to look at the database structure and see what tables and columns and maybe what the data types are for the specific columns. You're actually looking at the schema file instead of actually looking at the database when you do that inside of Studio. If you get ready to create a form in Genero Studio and you've got form items that are based on database tables, again, it's not having to actually go out to the database and connect to it to get this information. It's just looking at your metaschema file. The application generator uses metaschema files. That .4dbx that we just talked about is the application generator version of the same schema file that we work with regular projects. Just has a few more things in it for code generation. Now there's another schema file referred to as the BDL column definition file, and it has an extension of .sch, and it also has database structure information, specifically definitions of the database tables and columns. And we use that .sch file anytime you compile a BDL program. Now it's not actually used, neither one of these metaschema files are actually used when you actually execute a program. When you execute a program, it's actually connecting to the database that you specify in the application. So these metaschema files are used pre-execution for building and developing your projects. So this schema.sch file, this video column definition file, automatically gets created. So if you have already provided the .4db file, then it will automatically create this .sch file that it needs for compilation when you compile. Or there is a menu option. Under the database option in the menu for Studio, there's an option to create the schema file. Usually you don't need to create it manually. It'll take care of it all by itself. So that's a bit of information about the database schema files. They are required anytime you're working with databases. So how do you create a meta-schema file? There's an option in the Genero Studio menu, a database menu option called Extract Schema. So I went ahead and deleted my schema file just so we could walk through that live so you could see it instead of having to just look at the slide. So let's go ahead and take a look here. So notice I don't have a schema file in my special database library that gets automatically created when I create a simple project. So I'm just going to go up here and create one. Here's this database extract schema option. Starts up a dialog here. We have a wizard, and it wants to know, first off, where do you want to store your new meta-schema file on disk? So that's this meta-schema file path. So this looks fine. BDO class source day 2. It's picking that up because I have already created it once before. And then you give it a name. So this is a meta-schema file for the Office Store database. It looks like I've already got one. Hopefully it won't bomb. Hopefully it will just override it. So I'm just going to call it officestore.db. Remember, your schema files end with a .db. And then down here, you're going to insert it into the project, and that's what this special databases library node has been created for. That's the idea for it, is to store your meta-schema file there. So I'm going to go ahead and store it there in the databases node. Well, rats. It's not going to let me go on until I actually finish it up. I'll tell you what we'll do. We'll just put it somewhere else. That'll be a bit quicker. So we'll put it in day 1. We'll see if that works better. Doesn't like my destination directory either. All right, now maybe it's happy. Okay. Wasn't paying enough attention. So here we're going to put it in this BDO class source, and we're going to call it officestore.4db. And again, we're going to stick it here in this databases node in our project tree. So now it lets me click Next. And here in our database connection information, it defaults to Informix. It's the most common database used with Genero, but we're going to use this SQLite sample database that comes with the Genero installation, the Studio installation. So I'm going to change my database type to SQLite, and notice when I change the database type, it's smart enough to go ahead and pick up the driver for me. DBM SQT3XX is the name of the database driver that we need to use for SQLite. Now, if you have connected to the database previously, it's smart enough to keep your previous connections here. So I'm going to cheat a little bit and use that so I don't have to type all that in or browse for it. Otherwise, if I hadn't already done this before, this would be empty, and I would have to go down to this database file field, and I can browse for it here. Now, once you've got all of your settings, you can go ahead and click this Test Connection button down here at the bottom, and then you can see for sure if you've got the right path or if it's able to connect to the database. So connection to database successful. So that looks good. So now I can just go ahead and finish. And if it's able to extract the schema from the database after connecting to it, if everything works okay, it should go ahead and pop your schema file, your new meta-schema file information here in this working area. Over here in my project view, Notice now I have this officestore.4db schema file here in my project view. So that's how you extract a meta schema. It's pretty straightforward. So there's some of the steps that we just went through, connecting to the database, doing a little test to make sure the connection was successful. And then they're showing you that once you finish, it should go ahead and open up that schema file so that you can get a look at it as soon as you finish. Now notice over on the left-hand side here, let me pop this up again, there's this DB schema tab down here. So that screenshot that we just saw already had this DB schema tab open. So right here is where you can go and examine all your tables and columns and data types and so on. Something else that's pretty neat about the meta schema is that it extracts that from your database, but for purposes of development, you can actually enrich the meta schema and add things to it that aren't in the actual database. So over here on the left-hand side, we've got this database structure view. Let me get it up here where you can see it well. And you can actually go in and make changes to the meta schema file right here in this database structure and properties view. So right down here are all the properties. You've got table properties, you've got individual column properties, things like the data type, length, not null, constraints, and so on. Labels that you want to use whenever you're developing a form that might have this column in it. You can actually specify the type of widget that you want to be added to the form and the label. So a lot of things you can do here to enrich your meta schema, make development easier and more consistent for all the developers, and it doesn't affect the actual database. Now let's say though that you've made some nifty changes here. Let's see, something that's easy. Let's say, for example, that I decide to go in and delete something. Decided during my development process that I really don't need this catalog picture column. So I can actually delete it from the meta schema file. I don't know if you can see that, but notice now it has a red X on it over here in the database structure view, which is a hint that it's been deleted. But over here in the actual working area for the database schema view, notice that that cat pick column has been deleted from the category table. So one thing that's kind of nifty about Genero Studio is now you can actually create a database update script. Let me just show you that real quickly. I thought this was a neat enhancement. So here we tell it what the SQL, tell it that SQLite is the target database so that all the SQL data DDL statements, data definition language statements, will be standardized for SQLite. You have options for generating primary keys, foreign keys, lots of options here for what you want to do. And then I'm just going to click the generate option so you can get a quick look at it. So this is very neat. It actually creates a script that you could use to update the actual database and make the changes that you've created in your meta schema file. So we're kind of going backwards. So instead of going from the database to the meta schema, we can go the other way. So here's the main. It's just an FGL, a VDL program. Here's our main, calling a couple of functions here to drop and add tables if that turns out to be necessary. Now one thing that's pretty nice about it is it creates a backup file or a backup table. So drop table category backup is the first statement here in this function. And what it's doing is assuming that maybe I've already made some changes to the category table before, and it's very possible that there could already be a backup copy of that table out there. So it drops one if there's already one currently there and creates one that is identical to the table before the changes are made. So notice in our example that this special cat pick column that I just deleted in the meta schema will be in this backup copy of the table. So what it does is creates a backup copy of the table as it is before my changes, and it's actually going to copy all the data that's currently in the original table to the backup table. And that's just in case I change my mind later. Maybe I decide later that I want to go back to the original structure for that table. So that's a nice feature to create that backup table. And then once it's done that, then it goes ahead and creates the new table with the columns, data types, sizes that I've specified. In this case, the only difference is that notice that cat pick column is not going to be in this new table, and then it goes ahead and loads the data back into the table. So it's a very nice new enhancement to our metaschema management. It actually creates a database creation script and a database update script if you ask it to. So in this case, we were looking at an update script. All right, so we're not actually going to run that script because I don't really want to edit that table, so I'm not going to save it. And then over here, I've changed my mind. I don't really want to delete this guy. So I've got this revert option. So I've changed my mind. The revert option says, well, these are the changes you've made to the schema, so what do you want to undo? If I've made several changes, I can pick from the list and only undo the ones that I like. Right? So I'm going to go ahead and select this one. It's the only change I've made, and revert. And of course, when I revert, there comes my cat pick column back again. So some very nice features for databases, I think. Especially if you're not a DBA, it makes things a lot easier to work with the database, and of course, working with your forms as well. You can do all these things to kind of prepare what your form will look like so that each individual form doesn't have to be customized so much. So that's more about the metaschema. Now, something else you'll need to do with an application that connects to a database, and there may be some additional libraries, like perhaps you have some C libraries that you use some functions from. We have this option to go in and link dependencies. So for linking dependencies, we can link in libraries that might have some external functions, for example, in them that we want to link in to the project. Or in our case, it's actually this database metaschema file. See if we can get rid of all that just by popping over here. I don't want to save that after all. Whoops. Here's my application. So for my individual application, if that application has a dependency for, let's say, the specific Office Store metaschema, then right here in my dependencies, I can select this databases library node, and that way it knows that the database metaschema is a dependency, and it knows where to find it. So that's advanced properties. You'll actually be doing that in your lab this afternoon. If you do the lab, that will be one of the steps in your lab after you add a metaschema file to your project. So we have a schema statement that you add to your BDL program. Now this schema statement does not connect to the database, right? Remember, the schema is just this metaschema file that's totally separate from the actual database. So this is just referring to the specific metaschema file that this application needs to use. So we're going to use that. It's actually used in a variety of places. Anytime that we define a record like a specific table, for example, or a variable like a database column in general. So here's an example here. If I'm going to define this record and specify this nice shortcut defining a record like a specific table, that means that all the members of the record are going to be identical to all the columns in the table. The names of the members as well as the data types and sizes will be identical. So if I use that method to define a variable or a record, I have to make sure I have this schema statement in the BDL program. And it has to be placed above any variable definitions like this that are referencing a database table or column. So just referring to the schema that the BDL program is using for doing things like defining variables and records. Now the actual connection to the database is a different statement, right? So we can use the database statement or the connect to statement. If you're just working with databases in unique session modes where you just have one connection to a database by a given user, then you can go ahead and just use the database statement. If you want to open multiple sessions, perhaps all of those sessions are to a specific database or perhaps they're to different databases, then you need to use the connect to syntax for the connection statement. So here's examples of both. Got our database office store. There's our database specification there. And this one, of course, is for Informix. So database at database server specification. And then down here we're using the connect to show an example of starting up multiple sessions. Each session is named, like here's session A, they're calling SA, and then immediately after they're actually creating an additional session, session B. And then you can switch between those sessions in the application in the code. When you're finished, you can disconnect from a session with the disconnect, or you can actually use the, well, actually you don't need to use anything, right? When the program ends, that will work as well. So you can disconnect, as you see here, or when the application ends, of course, it disconnects any connections. Using SQL to retrieve data. We talked, I think, a bit about static SQL yesterday and the ODI driver and how it will actually map SQL statements that might be a bit proprietary. Sometimes folks with Genero a lot of times are coming from an Informix environment, and Informix has enhanced its SQL, right? It's not specifically ANSI standard SQL, and there's some clauses and SQL statements in there that are not considered standardized. So in some cases, the driver, or ODI, can actually remap these non-standard SQL statements to something that the database you're currently using understands, and in other cases it can't. So we'll talk a bit about that, and you can find all the specific examples in those SQL guides that we have for each one of our supported databases. So I'll point those out with you maybe towards the end of the session. Point them out to you. They're in the BDL user guide. They're a subset of it. So static SQL can be embedded in the program, and again, only a limited number of SQL statements are supported as static SQL statements, and here's an example of one, a simple select statement. But dynamic SQL allows you to execute any SQL statement. You use the prepare and execute statements to prepare a SQL statement, which then gets sent to the database server, and the database server allocates resources for the dynamic SQL statement, parses it, optimizes it for an execution path, for example, and then you can execute it pretty much anything that you can come up with that's standard SQL. Right, so prepare S1 from, oops, went forward a little bit too quick, update account, set last name equal, where user ID equal. We'll talk more about the syntax there later on. We'll actually be using some of these prepared statements. And then execute using some values that perhaps the user has been allowed to input, LName and key. So there's an example of preparing a statement, kind of completing a where clause by allowing user to input data. And then, of course, at the end, we're going to free all the resources allocated by the prepare with the free statement. And we'll see this again. This is just a quick example. Writing portable SQL. If there's any chance that you might be migrating to a different database, or if you're working with different databases now, perhaps not all of your information is in an Informix database. Maybe some applications need to access a different database. or perhaps two different databases in the same application, then it's important to have portable SQL. Some ideas to try to prevent having too much proprietary SQL is to follow some of these suggestions. So try to avoid statements in programs that create or delete databases or database-related structures. Tables, for example, or indexes. Some of those are going to be proprietary database specific. So see if you can avoid having those in BDL programs. Data definition language statements in programs, try to avoid those. Again, here we're creating databases, possibly database server structures, and here they're talking more specifically about tables, indexes, columns, and so on. The third one, using portable data types. Try to stick with, for example, ANSI standard data types. A lot of the databases, probably most of them, have enhanced data types that you can work with. Informix is a good example. It has all kinds of data types that are not strictly ANSI standard. And likewise, when you're working with BDL, try to make sure with your BDL programs, when you're interfacing and interacting with databases, try to make sure that the data types that you use in your BDL programs match data types that are supported in your target database. So that all has to do with portability for data types. Try to use portable data manipulation language statements. And again, ANSI standards. If there are SQL statements that you've been using because they're handy and convenient in Informix, for example, hold cursors would be a good example. Those are proprietary and they're not supported with all the different database flavors out there. So try to avoid using any DML statements like that that use proprietary syntax. And that's if you think that you may be working with different databases in the future or migrating applications to different databases. One last thing here, implementing optimistic locking. We'll talk more about this later, but for example, sometimes we use an update cursor to scroll through a results set and perform an update on a selected row. Update cursors do some locking, right, to make sure that no one else can get in and make any changes to a specific row between the actual select statement that we're doing with our update cursor and the actual user update. And that might be a long period of time, right, between when the actual, when the user actually goes out and does the query and opens the update cursor to the point where he actually does the update. So that's considered what they call pessimistic locking. You're trying to make sure that all the rows that you have selected are not changed for as long as you are looking at them. Optimistic locking doesn't lock the rows while we're just looking. Instead, or at least doesn't exclusively lock the rows while we're just looking. Instead, it waits until the point where we're ready to do an update. And then we go out and try to lock the row, of course, with the update statement. We might do some checking first, of course, with optimistic locking to make sure that no one has made a change to a specific column or row. But that would be built into the code instead of using a SQL statement to lock the rows. And again, we'll come back to that later and talk about how optimistic locking is implemented. And you can decide, of course, whether or not you want to implement optimistic locking depending on whether you need the portability. Right? If you know you're going to be migrating or working with different databases, or you have a lot of concurrency issues because users are having trouble with everything's locked all the time and they're getting errors, you might want to actually give optimistic locking a try. Less concurrency problems with optimistic locking. There's some good discussion on portability in the Genero BDL user guide. We've also got these SQL adaptation guides that I was talking about earlier that are a subset of the BDL user guide. You can find them in there at the bottom, I think. May not be all the way at the bottom, but they're in the BDL user guide. And all of those have specifics for each individual database on what's portable and what's not, and how non-portable statements will be mapped to that specific target database. Very useful for migrating to a different database. Just some examples of portable DML statements. We mentioned earlier, or we talked earlier, that the Open Database Interface can do some mapping of, let's say, proprietary type SQL syntax to standard syntax that will work with any database. And here's an example of that. Here's an update statement to update a table. Set table.star equal to a record.star. Well, that's not exactly ANSI standard, so it's not supported by all databases. So if you're using a different database that doesn't support that syntax, then the Open Database Interface can actually remap that SQL statement to something that is supported. So it actually converts it to this statement. Update table name, set column equal value, and then a value list. So in some cases, it can actually convert those SQL statements at runtime to something that's supported by the target database. But there's a few things that are not converted, and here's an example down here at the bottom. So here's a statement, update table, set table.star equal a specific value list. That syntax is not supported by all databases, and it will not be converted by the ODI either. So that will actually generate an exception with some databases. So you have to watch out for those. I actually got that example out of one of the SQL adaptation guides. So that's where you find all that information about what's portable and what's not portable there for a specific database. Identifying SQL errors. There's a special built-in variable. This SQLCA stands for SQL Communication Area. Is a predefined built-in variable. It's a read-only record, and it's filled, updated, anytime you execute a SQL statement with an application. And so it's common to go in and check the results from this SQLCA record to find out for sure if a statement was executed successfully or failed. And in some cases actually get the SQL error message if you like, because that's also one of the members of the record. So there's a lot of different types of information. Not all of it has to do with errors in this SQLCA record. The SQL code is typically what we check at the end of a SQL statement when it's executed to see if it succeeded or failed. That'll have our SQL code, error code in it. Here's the full error message here, SQL error message. It's a character field. And a lot of these other members of the record are database specific, right, depending on what database you're working with. And of course some of them are not even supported by some databases. There wouldn't be anything you could look at. And some of them are not used, like this SQLERRP member. So here's an example, what you might see in an application to check to see whether an executed SQL statement succeeded or failed. They're checking this SQLCA SQL code. 0's good. Right, so if it's 0, that means everything worked okay. So they're actually setting a variable based on that. Fetch OK equal true. Anything other than 0 is a fail, right? The SQL statement failed. So anything other than 0, there's a special built-in 100 SQL code, status not found, right? So 100 or not found means that no rows were returned by, let's say, for example, a SQL select statement. So there's some special built-in constants for this guy as well. We'll see lots of examples of using that SQLCA record when we start looking at code snippets later in the book. All right, so that's it for the Working with Databases chapter. That took almost an hour. So I'm going to suggest that we probably won't finish all 3 chapters today. We'll probably do 2 of the chapters, and then we'll probably just do maybe half of the forms chapter, maybe just a small part of it, but we'll go ahead and try to start it today, and then we'll go ahead and finish the forms chapter tomorrow. You know, it's close enough to being at the end of an hour. Let's go ahead and take our 10-minute break now, if you like. Chapter 5 is on the user interface. We've got a couple of chapters on the user interface today. We've got this chapter on displaying data, and then we also have another chapter that's our introduction to forms. We have at least 2 chapters that talk about forms this week. It's a big topic. So at the end of this module, you should be able to interact with the user with windows and forms, messages and menus, centralize attributes related to the appearance of the user interface with presentation styles, interact with users with interactive dialogue statements. Now actually I don't know that you should be able to write interactive dialogue statements yet. Maybe a better description would be able to describe the interactive dialogue statements. We'll actually talk more about interactive dialogue statements all week this week. So this is our first introduction to them. And then we'll talk finally, the very last page I believe is defining and displaying records. This week we've been using the Office Store application for a lot of the examples, and this is no exception. This is a screenshot of the Accounts application, I think, using the web client. And the application here is opening a window with a form to display data or present data to the user. So parts of the user interface we can see here visually are the form. We can't see specifically styles and all of those types of things that are a part of the user interface. We may not be able to specifically see some of the smaller pieces of the user interface, but they're there. And if you remember from looking at the debug tree yesterday, you can see every component of the abstract user interface in that debug tree, that read-only representation of our DOM tree. All these XML nodes, XML once they're loaded into memory. So the form files, one of the things that are nice about the form files that's giving us our appearance here of our display is that they're created in their own special files independent of the application code. So the presentation of the user interface is separated from the application code. And that makes the forms reusable forms. So I could actually have another application that used this exact same form, and that wouldn't be any problem at all, right? So the form files are actually independent files. We've talked a bit about form files already. And we'll talk about all the pieces and parts of a form file in the Forms chapter, and in some part today as well in this chapter as well. So here we've got some menu options up at the top, and those menu options are probably, some of them at least, are defined in a menu statement in the application code. And when a user selects an option here in the menu, underneath the covers in the application, he's triggering what we refer to as an action. And then, of course, there's action handlers in the application code that determine what happens when a user triggers one of these menu options or selects one of these menu options. So that's going to be a big topic of conversation here for the next day or two. So we're talking about centralizing the appearance of the user interface, and one of the methods we use to do that is presentation styles. So presentation styles, the whole object is to centralize attributes related to the appearance of user interface elements. It really helps to make development a lot easier and more consistent. It gives a more consistent look and feel to the user interface when you use presentation styles, because you can set all these presentation styles up in one place, and then all your different developers have access to the presentation styles and don't have to try to figure out, for example, what type of font to use, what color of font, background colors, all of those type of things, because you can define these presentation styles and centralize them, and then everyone can use the ones that have been, let's say, predefined. So elements in the abstract user interface that reference a specific style attribute automatically get all the values defined for that style. And we'll see examples of this shortly. Elements that don't reference a style use the global default. So there's always a global default So if there's something that's an optional configuration, you can kind of count on a global default. And we'll see that again and again today. So presentation styles, there's a default presentation file called default.4st. These are called resource files. We've got lots of resource files with Genero that you can use to centralize things so that everyone doesn't have to kind of reinvent the wheel when you're doing development. So presentation styles is the first resource file that we've talked about. Resource files all have their own different extensions, and so for presentation files, it's a .4st, short for style, I suppose. So notice the default style file that comes with your Genero installation is in this FGLDirb, that's your BDL installation directory, under the lib subdirectory. You can also create your own presentation styles file. Probably the simplest way to do it is to create your own style file, make some changes to the ones that are already there, like you could make a copy of the styles file, for example. Make some changes to it, add some things that you liked or wanted to add, and then just call your presentation styles file default.4st. And if you put that presentation styles file in the same directory as your programs, in your program directory, it'll automatically pick up your default.4st file instead of looking for that Genero default in FGLDir lib. So that's one way to replace the default 4st file. There's lots of other ways too. We'll be looking at some of these other methods as we go along this week, but think of that method first. You can always create your own, call it default.4st, and put it in your program directory. Here's an example of a presentation styles file. The resource files that we'll be talking about this week, like the styles file, is all XML. So again, portable. It's all part of the user interface, becomes a node in our abstract user interface tree. So you can expect all these different resource files to look similar to this. They're all XML. So the example we've got here is from a user-created styles file called mystyles.4st. And we'll learn different ways that you can load these styles files besides just calling it default.4st so that it gets picked up automatically in your program directory. There's additional ways to load them. So here's an example. We've got various styles. Let me grab my highlighter here. Styles all have a style name, and then they have a list of attributes. Now there's no way that I or most people would be able just to look at a specific object like a window or a form, for example, or any particular a label. Just about everything can have styles applied to it. There's probably no way most of us would just automatically know what all the possible attributes and settings are, possible values are for those attributes for an object. So that's why it's important to get familiar with the documentation. For example, I might not know that there's such a style attribute as window type, right? And I certainly wouldn't know all the different possible values for this attribute called window type. So let's take a quick peek here in the documentation before we go any further. Because when you start working with styles, I think the documentation becomes important very quickly, because you won't know how to configure your styles if you don't know what's available. So I'm just going to try doing a search on presentation styles. And what I'm really looking for is this topic right here, the style attributes reference, because that's what I'm really interested in, are all the different attributes that I can configure styles for a specific object, or all the different style attributes that are possible. So here's a list. This is the style attributes reference, and there's some common style attributes, and notice it says all these common style attributes apply to any graphical element, windows, layout containers, form items, anything. So here's a list of all the different objects that can have styles applied to them. Notice the list is pretty long here. So common style attributes, background color, so you could apply that attribute to any object, border for a widget, Font family, font size, a lot of things to do with fonts are common. Form items that have an image, where do you want the image cache to be stored? Accelerators, we'll talk more about accelerators later. Text color, text decoration. So a lot of things that have specifically to do with colors, borders, and fonts are common style attributes. So any of those presentation attributes you can use with any graphical element. So window style attributes is what we are actually looking at now in our PowerPoint presentation. But just notice you can even apply styles to buttons, checkboxes, labels in your form, messages, error messages. Just about anything can have a style applied to it. So this actually is not an exhaustive list here because I see a few things that are missing here. Probably somewhere else in the documentation. All right, so using that documentation, you can figure out for all these different objects what style attributes can be applied to a specific object. Like for windows, there's quite a few of them. Window type, sizable, border, action, panel position, ring menu position. There's a lot of different attributes that are available for window objects. You can, for example, if you don't know what window type is, you go to the documentation, you find the different attributes for window objects like we did a few minutes ago, and then you can actually click on the different attributes and see a good description of exactly what attributes are available and what they do specifically. Like, for example, this window type, one of the available values is modal, which means that this window defined with this naked style, window.naked, and naked is the name of the specific style, will be on top of the other windows. That's what a modal window type does. So you could actually make your own styles. We'll look a little more at that shortly. Or create your own styles file and kind of customize your styles that you use. And these are all coming from defaults that we're looking at here. The names of the presentation styles determine how they can be used or their priority. So this first one, style name equal window, that means that this style is more or less the global style and will automatically be applied to any window object if you don't specify a different style for that object. So that's the global style. If there's no dot and then specific name syntax, then it's global. But it is specifically for Windows. Here's a style that has to be named or applied to be used, this window.required style. So someone has configured that at some point. I think it's one of our, actually that doesn't really look like that's a default one. So this one's been configured and someone has picked out all the different attributes that they would like to see for a required values in a required window, and they've set up this specific style. So now I can apply this style to a window by naming the style, required style. Here's styles associated with label objects. So this is a global, again, a global style that can be automatically applied to all labels. Here's another style that's very specific, int search, that can only be applied to text edit widgets to provide the integrated search facility that we have for text edit widgets that allows a user to do a Control F, to bring up a search window. And then this dot urgent style down here at the bottom, notice that there's no object type associated with that, so that means that that style could actually be applied to any type of object, but it will only be applied if you name it, right? If you associate it with that object. So that's the priority. They'll use the global styles unless you specify a specific style or apply a specific style. So how do you apply a presentation style? Well, there's several different ways to set the style attribute for an element. You've got the attributes clause in the actual VDL code that you can use. The open window statement, for example, you can use an attributes clause with that and specify a style. Messages in the code, you can associate a style with messages or errors, messages in the actual VDL code. A lot of times you'll see presentation styles applied in the form. So there's 2 or 3 places in a form specification file where you can apply a presentation style. For example, in the layout section of a form, if you apply a style like they're doing here, then the style attributes for that required style in this example apply to all the elements in the form. So that's a good place to put it if you want it to be kind of a universal style for all elements in the form. But you can also apply a style at a lower level in the form, and this is in the attributes section of the form. So we're just applying a specific style here, this urgent style, to a specific edit field, right, an edit widget. So that's how you can apply a style individually. Now if it's applied down here at the attributes level, that would override anything at a higher level. Same thing for if I'm using a presentation styles file and I have that default style files sitting out there in my program directory. If I set it here in the form, it's going to override that default style file as well. So this has a higher priority here in the form. And then finally, down here at the bottom, hard to see, but you can also use the DOM API or a built-in class method such as setElementStyle to apply a style dynamically at runtime. So all of these form components that we're looking at, all of the user interface is part of that abstract user interface tree that we've talked about a few times. So you can manipulate anything in that abstract user interface tree dynamically at runtime. So we have special classes and methods that you can use to do that. Switching gears here, opening windows and forms. So we're leaving presentation files just for a second, or presentation style files for just a second, to talk a bit about opening windows and forms. All things that have to do with the user interface in this chapter. So a program creates a window. There's an open window instruction that's used for that. And if you use the open window with form syntax, that's going to open the window and open the form at the same time. And then you can use the close window syntax to close the window and the form simultaneously. So that's this first example we see here. Open window, WAccount form, with form, and then the name of the form. Notice that you don't have to use the form extension. You don't have to specify the suffix for the form, just the common name, no suffix required. And then when we're finished with the window, we can close it with the close window statement. Down here's another example, and this time you do see for Windows, one way to apply a style is with the attribute clause. Again, there's multiple ways to apply styles, so this is one method. I don't think this is usually considered to be the best method for applying a style to a window, but it's one method. So style equal and then the name of the style. The runtime system creates a default window named screen. And the reason that default window is there is primarily for folks that were migrating from Informix environments to Genero environments, to this new, more graphical environment. So they used forms, and this gives them a way to just, I guess, inherit a window, for lack of a better word. And this window is available for the display of a form, right, for the display form statement that we have in a lot of those legacy 4GL programs. But you can use this screen default window if you want to, or you can close it with the close window screen statement and get it out of the way. Let's take a look here. Simple application based on the lab that you'll be doing this afternoon. We can use it to look at some of these statements that we're talking about. Notice up at the top that we've got our schema statement, right, because we're going to be using the schema, the Office Store schema that we just extracted a few minutes ago in the database chapter. So I've got it up there. And then here I've got my actual database connect statement here, connect to Office Store. And then here's this statement that closes this special default window called screen. Let me show you what that looks like if you don't do it. Let's just comment it out and save it. See what happens here. Yeah, see this funny little window that pops up over here to the side? That's that default screen window. It looks funny out there because we're not actually displaying a form to it. We're not actually using it for anything in this application. So instead of having that just hanging around out there, you can just use this close window screen statement, and that gets rid of that default window that pops up like that. Let me save that so it won't pop up again. And here's our open window statement. Open window, you give your window a name, and then you can specify a form that you want to open with the window. And then here's this attributes clause that we just saw that you can associate optionally with windows. So style equal my style. So there's an example of some open window with form statements. So we already saw window styles because we were using those as our example of what a styles file looks like, what the XML looks like for a styles file. But we did see already that we have this default style called window, and that was our global style. So if we don't specify a specific style for an object, it's going to get the global style, which in this case is just the window style. There's a couple of styles, main and main 2, that are typically used for starter windows, if you're familiar with those. And then typically other application windows are displayed within those. They're kind of container type objects. We've got a couple of, well, 3 or 4 different dialog styles here for dialogs. Those are typically windows that are modal windows that pop up a lot of times to allow the user to respond to a question like, do you really want to delete, yes or no, that type of a thing. So those are typically what dialogs are used for. They're kind of like what I would call more of a pop-up type window. They come up as a separate window. Naked, no menu, no action buttons, probably limited uses for the naked style. And then there's a viewer style too that we use, for example, for viewing reports. There's really nothing there that you can do with the window. No menu, no action buttons, just the cross button on the upper right corner. So not much decoration or user interaction with a viewer style window. So there's some of our window styles that we have in the default.4st file. Messages. If you decide to display a message to the user, for example, perhaps you've got a query by example application where you're letting the user go in and do a query and it returns a set of rows. You might send them a message or give them a message relating to how many rows were returned. That might be an example of a message you might want to display. But messages also have style attributes that can be applied. Not as many as windows, of course, window objects, but there's some here that have to do with the way the message looks, right? The color of the displayed text, the font attribute, video attributes. That's kind of old technology now, but basically things to bring that message to the user's attention. Bold, invisible, that would be hard to bring to a user's attention, wouldn't it? Normal, and so on. Errors. You can also apply styles to error messages. Same attributes that we just saw appear in this table for message instructions. There's an example of an error message. This one doesn't have any style applied to it, but if you wanted to apply a style to the error message, you'd do it just exactly like they've done up at the top here with the message. Attribute, style equal, and then the name of the style. So that's displaying messages and errors to the users. We have a section now on what they call interactive dialogue statements. It's various statements that you're probably already familiar with in the applications that turn control over to the user. They're allowed to interact with the user interface when you're working with these interactive dialog statements. So they're very high-level BDL statements. They substitute for many lines of codes, so it's shortcuts using these BDL statements. And typically, each one is associated with a common task. For example, menus, which I think everyone is familiar with menus, allows the end user to select from a list of actions. And then based on the action that they select, we're going to execute some code based on the action that they triggered. There's a construct interactive dialog that allows a user to enter database search criteria to query the database and return a row set. There's display and display array interactive instructions or interactive dialog statements that select information displayed from database tables, or display information, and the users are allowed to scroll through and select information from the display statements. Input and input array interactive dialogs allow the user to modify the database by adding, updating, and deleting data. So there's all examples of common interactive dialog statements, turning control over to the user to perform some type of task. We've talked just a bit about actions. The user interface typically does have some sort of interactive graphical element, like a button, that allows the user to interact with the user interface. For example, menu options are associated with actions, and when a user picks a menu option, he's triggering this underlying action, and then we're going to execute some code based on the option that he selected. So actions are just events that are triggered by these interactive elements like buttons in the program. You might be using toolbars or top menus. Toolbar items are items that are associated with actions too, just like a button. Menu options from top menus, top menu items, are also essentially action views that are associated with actions in the code. So actions, when the user triggers an action, are transmitted to the runtime system to be interpreted, and then we handle those with action views. And again, that would be our buttons, our top menu items, toolbar buttons. And then action handlers are in the code. The action handler is just the code that you've got in the program that determines what happens when a user triggers one of these actions by selecting a specific option. Action views are just the graphical objects, right? The buttons, toolbar items, top menu commands, and so on. Action handlers are the code, and it's defined with an on-action statement or an on-action clause. And that on-action clause is going to execute some instructions. So any of the interactive dialogs, the ones that we just talked about, menus, input, input array, construct, display, display array, all of those can be associated with actions. So when a user selects an option, that triggers an action, right? The action view, the button or whatnot, triggers the action. They're calling it an action event. And then that action event gets handled by the code that you have in the BDL program that we're referring to as the action handler. Just on action clause and then whatever you have after the on action clause. Here they're talking about action binding. So how do you associate a specific action in your program with an action view like a button? Right? So let's say I've got a button in the form, a button in the user interface that the user can select. How do we tie that to the code? And the answer is this action name attribute. A lot of times people confuse the action name with the text that you see on a button, for example, like the print button in this example. But what the user actually sees in the user interface that says print is actually just text. That's the text attribute. What we're interested in here for this action view binding is the name, the actual name attribute. So in the code, we can specify on action and then specify the name of the action view, right? The name attribute of the action view. So those two things have to match. So this is a .per specification file, and here's the button that's defined in the .per file, the text file, and here's the button B1. That's the form field association or the form association, and then the name of the button is print. So that part has to match what we've got in our code. So on action print, and then the button name print. And then the text attribute, this part over here, is what the user actually sees in the user interface, the word print. But it's not the name, it's just the text. And it has nothing to do with the action binding process. There's something else I was going to tell you about that, but for some reason I'm drawing a blank. I'll probably remember shortly. All right, let's take a peek at a real one, a real application here. So just looking at the screenshots. So here we have an interactive dialog, very simple menu statement here, menu accounts, on action display. Right, so there's the name of our action, and then if we had a form with a button in it, then that button, the name of it would have to be display. Now it actually creates default action views for us if we don't have a button defined on our form. Let me show you that quickly here. Here's the form we're using with this little application. Notice there's nothing on here that's defined as a button, right? We don't have a button defined. So in the case where we don't have a button defined in the actual form, BDL is smart enough to go ahead and create an action view by default, kind of a predefined action view. So it will actually create buttons by default. Let's just take a look here. Go ahead and run it. Notice a minute ago we didn't see any buttons that were actually defined in the form, but notice when we run the program we do see buttons. Here's this display button that's matching up here with our on action display, and then we have an exit, and that's tying in with our on action exit up here in our interactive dialog, our menu statement. So by default it'll actually create these action views for you, and the default behavior, as you can see, is to create buttons over here. A special menu panel over here on the far right. It's got this nice box around it, and then it has buttons defined for all the actions in our menu statement, in our menu block. So that's the default behavior. Now if I go ahead and create, let me just do that real quick. Let's grab this form that didn't have a button predefined in it. I'm just going to grab a button here and stick it in. I'm sure you could make yours look a lot better than that, but we're just doing this for demonstration purposes. So I'm just going to throw that button in there. So notice when I pop it in there, it's just called button 1. Over here on the right, when we create a form, here's all the structure for our form. Scooch it over a bit. Scooch over a little more. There we go. So here's all of our structure for the form in the form structure view, so we can see all the pieces and parts to our form. Down here at the bottom, last thing here was our button that I just added, and here's the name property. So when you're working with a form designer form, it's not the name attribute per se that has to match, for the action view binding. It's the name property. So I'm going to call this display. Or actually, yeah, that works. But for my text, it really doesn't matter what I put here because it has nothing to do with the binding process between the on action clause in the code and the action view. So here in the text I could say, pick me, right? And that's perfectly fine. It doesn't have anything to do with the binding process. It's this name up here at the top, display, that has to match. So that's how you define a button in Form Designer and specify the name attribute so that it matches the on action name, the action name in the BDL program. All right, so I don't really want to keep that. The one it creates by default is fine with me. I just wanted to show you how to do that. All right, so on action display in our action view, if we create one like a button, for example, in the user interface, the name of that button has to match what we have here in the on action clause. So that's what we're showing you here, only in this example it's a .per file. So you see the .per file example here, and we saw the form designer example a second ago. Action defaults. A minute ago, let me just pop back right here. A minute ago we were looking at this form. This is a .per form specification file, and it actually has all of the attributes for this button, all the decoration we'll call it for the button here in this attributes section. The text, we could have some additional information about the button here that we wanted to use, and that's all pertaining to the action view, look and feel. But a better place to do it is actually in another one of these resource files, very similar to the idea that we saw with the presentation styles file. There's a special resource file just for action defaults to define the appearance, things associated with the appearance of these action views. So like presentation styles files, the whole idea is to centralize all the attributes for action views. Like maybe you're going to have buttons that are add, modify, delete, display, all kinds of different things. You can set them up one time with all their attributes defined for how you want them to look and feel in one of these action defaults files, and then all the developers will be using that centralized file for the attributes for their action views, and they won't have to try to reinvent the wheel. That way the look and feel of all the forms, all the screens in the user interface will be similar because everyone's using these centralized attributes, centralized settings. So same basic idea as presentation styles. So we're going to centralize the appearance of our action views in this action default files. Text, comment, images, image information, accelerator keys, and so on can all be defined in an action defaults file. And just like we saw a few minutes ago with presentation styles files, you can override it very simply by creating a default.4ad file to override the global default.4ad file. It works the same way. So if you'll just create one and put your changes in it and put it in your program directory, name it default.4ad, Genero will automatically pick up your action defaults file instead of this default one. So very similar behavior to presentation styles files. So action defaults, just like presentation styles files, these files are XML files, XML resource files. Notice the extension's different. Can't have the same extension for a presentation file as we do an action default file. So the extension for action defaults files is .4ad, action default. So here we have our action defaults file example. This happens to be the one for the Office Store application. So this is not really the default action defaults file. This has been a customized action defaults file for the Office Store sample application. It's called dbapp.4ad. And I stole a piece of it for our example for this chapter. So here's this action default list, and then here's all of our different names for our action defaults. So anytime we have a button, for example, named exit, it's going to automatically, or we want it to automatically pick up all of these special action default attributes that we've defined here. We want the text to be exit with a capital E, the comment for the button, if they kind of hover over it, we want it to be exit, Alt plus F4, give them a hint. The image that we want to use for the exit button we can specify here. And this way we set all these things up once, and then all of our developers have access to this without having to try to memorize what they're supposed to use for the exit button attributes. And then here's an example of loading an action defaults file. Now you've got the same basic idea for presentation styles. I just didn't show it to you earlier. But there's a special method. I've got this interface class load action defaults method that you can use to load a specific action defaults file. And notice you don't have to use the extension. You don't have to have the .4ad on there, just the basic name of the file. You can use that same method with presentation styles. We just haven't talked about that yet. We'll cover all of this again in our chapter on the built-in classes and methods. We've seen a menu already, but here we're finally ready to talk about the interactive instruction or the interactive dialogue menu. So here's a menu statement. Rats. 1 second. So we saw one of these in an application just a second ago, so I'll go pretty quickly. Here's our menu statement. Here's our on action statement with the name of an action here, on action new. And of course this correlates back to some sort of action view like a button or a top menu item, whatnot. And then right here is what they're calling the action handler. Right? This part right down here, anything after the on action statement here, on action clause, is considered the action handler. So when a user triggers the new action by, let's say, clicking on the new button, it's going to execute this code. Let next action equals C action add exit menu. And so we have actions defined here for all of our different action views that the user can interact with. We saw a minute ago that by default, if you don't define an action view, for example in your form, like we saw, you could just add a button there in the form designer interface very easily. If you haven't done that though, it will automatically generate buttons as a default action view for your menu actions, and you saw that in the program we ran a second ago. So it creates the buttons for you over in the menu panel on the right hand side. And then we had two different buttons here. One for the query on action, and on action exit also creates a default action view. Down here at the bottom, they're showing you some of the attributes. So we've got styles that can be applied to menus. There's only 3 styles, actually, 3 menu styles that can be used for menus. And you can't create your own menu styles. You're confined to these 3. There's the default style, which is what we saw already when we ran the application. There's also a dialog that causes the, it's more like a, what I would call kind of a pop-up, although that's the wrong term for it. Kind of pops up in its own little window, typically used for like yes or no type things. And then there's also a pop-up style that I would consider more of a context menu, like if you hover the mouse over it, you can see the pop-up menu. So you don't really see that without hovering over the mouse. So there's 3 different styles for menu buttons, and default, dialog, and pop-up. So you can specify the style here with the attributes clause, and then you can also specify a comment if you like. Here's the construct interactive dialogue. We'll see all of these in a lot more detail in the following chapters. This is just our introduction to them, but this allows a user to essentially input information to create a query, to query the database. So you can control what fields that the user is able to input information into with your construct statement. Construct by name is going to create a where clause from the results of this, the rest of this selection they do on account.userID and account.firstname. So we're allowing the user to enter a user ID and a first name in this example and create a query to query the database. And we'll see the details of how that works tomorrow. Here's a display interactive dialog. The example, select user ID, first name, and we're selecting those values into a program record, laccount.rec.star, from account where user ID equal blogs. So here we're loading a program record and then displaying the contents of that program record to a screen record, a matching screen record in this case. So display by name, laccount.rec.star. So a display lets us display some values in a program record and display it to the screen. The display by name that we saw a second ago is handy. That's one of the benefits of defining records like a database table. Some of the examples we saw earlier did that, because then when we get ready to use the program records, we have this handy display by name that we can use. We don't have to itemize all the different fields in the program record or members of the program record. Instead, we can just use this display by name syntax, and it will automatically display all the values to the matching screen record. So if our program record members and variables match what we have as screen record, our form fields and data types all match in the form, then we can use the display by name. If they don't match, then you have to use just this display to syntax, which is more tedious. There are benefits to using display to instead of the display by name and defining records like a database table. One reason you might not use the display by name or define a record like a database table might be because your database structure changes a lot. If somebody goes in and is always adding new columns to the database or deleting columns in the database, then defining records like a database table doesn't always work very well. It'll break if the database structure doesn't match what you have in your program record defined. So in those cases, you kind of have to avoid using the define like syntax and itemize your program variables. And that way, if somebody adds a new database column or deletes a database column, your program doesn't break. It may not have all the information displayed that you like, but at least it will run. Here's display array. So here's just a method we use to display a program array to the screen. So display array, and there's our array name, account_array, to a screen array, SA account.star. And again, the number and type of the elements in the array have to match the number of elements and types in the screen record, or it will break. Have to match. Here's the input statement, input by name, mr account.rec.star. There's a program record there. Field order form. Now when it says field order form, that just is referring to the idea that somewhere in the form specification file they have specified what we call a tab index, which is just the order that they want the form fields to be moved to when a user's working his way through the form, how it's tabbed through the form. The default is just the order of the input itself, the order that the fields are defined in the input statement. This attributes unbuffered that you see up here is fairly important. I would think most of the time you would want to use the unbuffered attribute, because what that does for you is it automatically synchronizes your program record with your form field values and vice versa. So let's say, for example, that in your application it programmatically changes the value of a member of a program record. If you're using this unbuffered attribute, it automatically will update the form field that's associated with that program member, that record member, automatically without you having to say display to, right? You don't have to rerun a display statement to do it. So it automatically synchronizes program variable values with the associated form fields on the form. and vice versa. If a user enters data into the form and, let's say, selects accept, that automatically updates the program variables with the contents of the screen record. So it kind of works both ways. So that makes a dialog, I guess the term is sensitive, right? It makes it sensitive so that the program variables and the form fields are synchronized automatically. Here's the input array, entering and modifying array data. So here's an example. The input array allows users to, basically the same as an input, except that we're working with an array instead of just a regular record, working with a set of values. We've got control blocks here. We're going to talk a lot more about control blocks as we go through some of these additional chapters this week where we're really focusing in on some of these interactive dialogues. But this is a good introduction. You've got control blocks for most of the interactive dialogues that allow you to control the behavior while the user is in the interactive dialogue. For example, here's a before delete. Whenever error continue, don't just bomb out of the program. If there's a problem, go ahead and continue until we handle it gracefully. Delete from items, where item num equal p items array current dot item num. We'll talk more about that a bit later on. But the idea here is that somebody has deleted an item from the program array, but we need to make sure that we have also deleted it from the database before we delete it from the program array and go on. So they're saying, okay, before we delete the item from the program array, we need to use it here to be able to delete from the actual database table. So that's a pretty commonly used technique. For working with databases, we have to make sure that we update the database to match. Here's the checking the SQL code. We talked a bit about that SQL-CA record earlier today. So there's an example of somebody using that. If it's anything other than 0, there was a problem with that SQL statement, the delete statement, and we want to cancel out of the delete operation. So there's an example of using that SQL record. And finally, working with records and forms, we just saw an example of what we're talking about here is when we're working with program records and forms, we also have to get underneath the covers to make sure we've also updated our database records, like we saw with the delete statement a minute ago. So you're not finished until you've actually updated the database. This one's a simpler example because we're not actually updating the database. We're just working with the database to do a select statement. So here we're defining a record. In this case, the name of the record is L-account record. It's got 2 members in the record, user ID. We're using that handy like keyword to define user ID like a database column, account.userid, first name like account.firstname. And then a select statement. Select user ID first name into our program record, laccount.star, from account where user ID equals, and then a specific user ID. So this is a very simplistic example. And then here's our interactive dialog or interactive instruction, display by name laccount.star. So that displays the contents of our program record to the screen record that's defined in the form. Okay, so that takes care of Chapter 6, which is just our introduction to the user interface and forms specifically. And we'll revisit forms again. We've got another chapter on enhancing the form where we're getting a little more in depth into forms and information about the forms. I think I jumped ahead of myself just there. Sorry about that. So we do have a chapter on forms today, right, that's coming up next. It is 5 after 1 though, so we're about to run out of time. So what I thought we might do is just get a quick introduction to forms here today, get a few pages in, and then we'll go ahead and finish up the forms chapter on tomorrow. So again, today we're just introducing ourselves to the concepts of forms and interactive dialogues, and as we go through the additional chapters we'll get into more detail. All right, 1 second while I go ahead and open up the next set of slides, and we'll just get a good start on the forms chapter. All right, so let's take a look at Module 6 just for a few minutes, and then we'll go ahead and call it a day. Chapter 6 is an introduction to forms. So by the end of this module, I don't know that you'll be able to define and compile a very complex form, but you should be able to define and compile at least a simple form. Describe the sections of a form specification file, and by this we're talking about the text-based files, the .per files. Remember, there's 2 different types of forms that we'll be talking about this week, and one of them is kind of a old-fashioned text-based forms that a lot of people still prefer. They still find them easier to work with, and they're comfortable with them. And then we've also got the graphical form designer interface that we can use to design a form graphically. It doesn't really matter, remember, what kind of form you're working with, whether it's the old text-based style of form or the form designer graphical form. When you compile it, you're still ending up with a nice XML form, right, that gets loaded into the abstract user interface when you launch your program. So we'll talk about form containers quite a bit in this chapter. So that's one of the big focuses of this chapter, is what form containers there are and what they're for. And then we'll talk about the form from database wizard that you can use to quickly create a form in the form designer interface. So that form from database wizard is just for form designer graphical forms. There's not an equivalent for that for per files, for the text-based files. So elements of a Genero form. When you work with forms, you'll be working with containers. Every form item has to be inside of a container. Most forms, especially complex forms, have sometimes several containers. When you start looking at forms like the Office Store forms that it uses for the order application, there's probably 5 or 6 or maybe even more containers out there that are nested containers. And of course the idea there with using these nested containers is just formatting a screen region or formatting areas on the form so that they look and feel like you want your form to look and feel. So that's the idea with containers. They're a way of kind of formatting a screen region on the form. There's lots of different types of containers. There's a simple grid container, which is probably our simplest type of container. It's typically used just for displaying contents of a single program record, for example, is what we typically use a grid container for. We've got vertical box layouts, horizontal box layouts, which determine whether or not the items in a form are laid out on the form from top to bottom. That would be a vertical box layout, or from left to right. Right? So when we define a form, we can specify whether or not we want items in the form laid out one way or the other, top down or left to right. We've got folder containers, page containers, which are not here, but we also have page containers that are used with folder containers. We've got table containers that we typically use for displaying of array data. Group boxes that are typically used just for formatting to make things look attractive on the form. And then various other containers we'll look at in detail. Form fields are just areas where users can view and edit data. So forms typically contain form fields, right? So the user can work with data. Widgets are typically user-friendly form items for an underlying form field. For example, a combo box allows a user to pick from a list of options. Now, let's say it was something like state. Maybe you have 3 or 4 supported states that you are for a region that you work in, and you want a user to pick a valid state. So instead of relying on him to type in a state name correctly, you can instead offer him a list of choices in a combo box. So we've got some handy widgets like combo boxes and radio groups where you can define radio buttons with an item list for users to pick between that make it easier for a user to select data. So that's a widget. And then an action view we've already discussed today. That's just a form item that the user can select that triggers an action in the code, right? The on action clause that we looked at earlier. By selecting a particular item or option or clicking a button, the user triggers this on action clause. And then we execute some code defined in that on action clause. And then a label is just a text area. It gives the user some more descriptive text, like perhaps the label for a form field to describe what that form field represents. So those are all common elements of a Genero form. Here's an example Genero form that's fairly complex, and this is from the Office Store application. This is the orders form. So it's a nice one to look at because it does use a lot of the different containers that we talked about earlier and a lot of the different widgets. Now there's some overlap, I forgot to mention, in the names of these things. For example, action view and widget, there's some overlap there. For example, a button is a widget, but it's also an action view. So the terminology they're using, there is some overlap. So you can call them, I guess, whichever one you prefer. So here we've got an example Genero form that has some action views defined. They're using a top menu, a toolbar. So there's our action views up here that have been defined. It's got lots of containers. Probably the first container we need to talk about is a vertical box container here that's aligning everything in this form from top to bottom. Right? So we have an area here, here, and here that's all been laid out vertically by using a V-box layout. So that's the first container that really catches my eye. And then nested within this V-box container are other containers. For example, this area right up here, I'm going to put a square around it, is an H-box. I almost said X-box. What am I thinking? H-box container. Right? Horizontal box container. So the items inside are nested within this H-box container. Notice they're aligned from left to right. So we have a V-box container that has an H-box container nested within it. So all the children of the H-box container are going to be laid out from left to right. But the H-box container is a child of the V-box, the vertical box container. So it gets laid out from top to bottom. Then we have a grid as well here inside this H-box container. This area here is a grid. So we have an H-box with a grid container in it that's just used for arranging these additional form fields like this order ID, order date, and so on. Then down here, got too much highlighter going on. Down here we've got a folder container, this area right here in the middle. And this folder container, billing, shipping, credit cards, those are page containers. So we have a folder container that contains 3 page containers. And then it's kind of hard to see, but we've got some grouped fields in there. It's probably easier to see the group over here. If you look at this item details down here at the bottom, see this line? It's very faint. This is a group box. Item details is a group box, and it's just to kind of enhance the appearance of that area of the form there. It's putting a box there around the image. So that's a group box, another container. There we go, got rid of the highlighter. And then down here we have another horizontal box, right, below the folder container. So down here is another horizontal box that has a table container in it. This area here is a table container that's typically used for displaying array data. So we've got an array that's being displayed in that table container. So over here is a widget. This is an image widget, but there's actually 2 types of image widgets. There's one that's a form field image widget, which is what we see here, and then there's a static image. You define them as one or the other. Form field image widgets are defined that way because they're changing frequently. So this one you can see is defined as a form field image because it's getting its picture, its image, from a database. So every time the user selects a different order with different items and those item details, there's going to be different pictures which will update this image field. So that's defined as a form field image widget. So there's a good example of a form that has a lot of these different containers and form elements defined. That one's fairly complex. That probably took some time to put together. All right, so maybe just one or two more slides and we'll go ahead and call it a day today. So Genero form files, two ways to define application screens, or two different types of forms that you can define. One is the .per files that a lot of you are probably familiar with. They're text-based forms that have a suffix or an extension of .per. We've also got the Form Designer interface in Genero Studio that is a graphical form designer tool. So I'll work quite a bit in Form Designer this week, or we'll tinker with Form Designer a bit this week to get you more familiar with it if you're not already. So it doesn't matter which one you're working with, both of them are compiled into these .42f files, and of course we've already talked about the fact that those are XML documents and get loaded into the abstract user interface when your program executes this open window with form statement. That's probably a good place to stop. This next section on form specification files is talking about the .per forms and all the different sections in that form specification file. So that will take a bit of time. All right, so let's call it good for today.